Hello, this is Abhijit and you are watching my YouTube channel AB Study Circle. Do like, comment, share and subscribe. In previous video lecture, we have discussed about basic concepts of thermodynamics, and continuing with that, in this lecture, we will discuss about some other basic concepts of thermodynamics. Now, there are types of thermodynamics. Types of thermodynamics. First is statistical. In statistical thermodynamics, we concentrate our study upon each individual molecule. Means we concentrate on the behavior of individual molecule due to energy transfer. And this type of statistical thermodynamics is used when we want to have a microscopic approach. And this type of thermodynamics or microscopic approach can be applicable or feasible when there are low density or at higher altitude. At lower density and higher altitude. Right. But the second type of thermodynamics, that is classical thermodynamics, is used when we want to have a macroscopic approach. Macroscopic approach. In this, the behavior of an individual molecule is not considered. Behavior of individual molecule is not considered and it is supposed that each molecule behave equally. That means there is no change in individual behavior of the molecule, right? This type of thermodynamics is basically we are discussing further in our lectures, right? Now, accordingly, we can now describe system in another way. Right? It is a prescribed identifiable and fixed collection of matter which is completely enclosed within a definite reason and whose behavior is being investigated. See, in previously we have discussed that system is a region in space upon which our study is focused. So, elaborating that, we can say the system is a prescribed, identifiable and fixed collection of matter which is completely enclosed within a definite region whose behavior is being investigated. Right. So previously I have discussed that this is a pen and it can be a system, and anything other than this is a surrounding, and we focused on the changes in the properties of the system, that is its pressure, temperature, etc. Right. So if we see the definition what we have given right now is, it's a prescribed, identifiable, we can identify it in space, it's a fixed collection of matter, yes it is a fixed collection of matter, which is completely enclosed within a definite region, yes we have a definite region upon within this, the matter, whose behavior is being investigated, and we are investigating its behavior upon the changes in the surrounding when this system is interacting with the surrounding, right? Now, as I have discussed this, we further move to a new term, that is control volume. Firstly, I want to draw the figure it's a motor, it's air compressor, this is your air output, this is your air input. See, in thermodynamics, basically the mechanical components or your open system. In the last lecture we have discussed about open system. Open system says that it allows both mass and energy to cross or interact with the system and surrounding, right? And when we are using thermodynamic analysis, we are unable to define the region in the space of the open system where our study will be focused or our investigation will be carried out. For that, we find a certain volume in space around that open system, as we know that a compressor is an open system. So in this example we are using a compressor as an open system, so a certain volume in space surrounding this compressor is known as control volume. This is known as control volume, right? And the region that is bounded is known as control surface, and we assume this dotted region, this shaded region now, as our system, and everything will be investigated according to this shaded region which we assumed as system. Now we have another term, pure substance. A substance is said to be a pure substance if it has a constant chemical composition throughout its volume. Constant chemical composition throughout its volume is known as a pure substance, right? Now there is examples, right? See, we have ice. In a container we have ice and water. Is it a pure substance? Yes, it's a pure substance. Why? Because ice has a chemical composition of H2O and water has a chemical composition of H2O. Now this container is filled with ice and water, means throughout its volume it has a constant chemical composition of H2O. So we can say that yes, it's a pure substance. Now there is another example. Water plus diesel. Is it a pure substance? It's non-pure substance because it does not have constant chemical composition. As water and diesel have different chemical composition, so it doesn't have a constant chemical composition, so it's not a pure substance. Again, someone will say that ice and water is not pure because there is a phase difference, because ice is a solid phase and water is a liquid phase. So note, this should be note, phase has nothing to do with pure substance. Means pure substance is only due to chemical composition and nothing to do with phase. Pure substance depends upon chemical composition and not on phase. Right? Now, moving further, we have thermodynamic equilibrium. A system is in thermodynamic equilibrium if it satisfy first thermal equilibria, which means equality of temperature. Yes. Now we have mechanical equilibria, equality of forces. Now the third is chemical equilibria, that is equality of chemical potential. Now, thermodynamic equilibrium will be achieved only when these three equilibrias, that is thermal equilibria, mechanical equilibria and chemical equilibria, are satisfied. Now moving to the most important concept that will be used throughout this subject is thermodynamic properties. Now you will say that what is property or thermodynamic property? It is nothing but it's a characteristic of the system, right? Characteristic of the system. Properties are of two types. Yes, they are of two types. First is intensive properties, intensive properties, and second is extensive properties. Intensive properties are those properties which are independent of mass. Extensive properties are those properties which are dependent on mass. Now, the examples of intensive property are temperature, pressure, etc. Examples of extensive properties are volume, all form of energies, right? Now there is some points which we have to remember when we are discussing about intensive properties and extensive properties. Firstly is that ratio of extensive properties is an intensive property. For example, density. Second, specific properties are intensive. Specific enthalpy, specific volume, these are intensive properties. Now moving further is thermodynamic state. Thermodynamic state. It is the condition, state means condition, right? It is the condition of a system, and at a given state, properties are fixed. Yes, it's obvious that properties will be fixed at a particular state, because these properties such as pressure, temperature or energy at a particular state will be fixed because they define the condition of a system, right? Okay, the next point is thermodynamic process. It is change of state. When there is a change of state, we say that it has gone through a system has gone through a thermodynamic process. Right. Now, there are some points in relation to properties which we have to remember, right? Points to be remembered in relation to properties. First, properties are state function. And they are exact differential. Yes, they are state functions because at a given state the properties are fixed. Right? Now, as we have defined properties, thermodynamic property, state and process, we move to our next thermodynamic cycle. When the initial and final state are same, we say the system has gone through a thermodynamic cycle. For a cycle, minimum number of processes required is 2. For example, let it be any space property, any property space, right? It can be pressure, volume, it can be temperature, entropy, it can be any space, right? Property space. Suppose it's state 1 and it is a state 2, right? One process, let it be A, from 1 to 2. There is another process which is from 2 to 1. This is the process B. Means the initial condition was 1. When it moves through A process, it reaches the state 2, and after that again it moves from 2 to the final state 1 through the process B. Now the initial state and the final state is the state 1, and now we can say that this system, which is moving from state 1 to state 2, then state 2 to state 1 again, has undergone a thermodynamic cycle. Note, the change in property for a cycle is always 0. How it is always 0? Because as we have discussed that property is a state function, means for a particular state the properties are fixed, and we say that a thermodynamic cycle is that when the initial and final state are same, means there is no change in the property. So we can say that the change in property for a cycle is always 0 for a cycle. Now there is a next concept of reversible and irreversible process. A process is termed as reversible if when reversed follow the same path without leaving any effect in the system or in surrounding. And the opposite is known as irreversible process. The opposite is known as irreversible process, means when reversed it doesn't follow the same path and leaves some effect on the system or in the surrounding. Then it is known as irreversible process. Again, I have to mention here that reversible processes are hypothetical processes. These are hypothetical processes. Means in practical environment these processes are not there, and these irreversible processes are practically available. Right? Let's give an example of a reversible process and irreversible process. Right? First of all, reversible process. Again, it can be any property space. It is state 2 and it is state 1. Let 1 to 2, the process 1 to 2 is forward process and 2 to 1 is reverse process. Now we are seeing that when it is reversed, when 1 to 2 is a forward process, and when it is reversed it follows the same path backwards from 2 to 1. Now, without leaving any effect in the system and surrounding. A reversible process is those which doesn't leave any effect on the system or in the surrounding, right? Now, suppose there is some heat transfer from the system to the surrounding, or interaction between the system and surrounding in respect of heat. The system and surrounding, right? I have to see whether this process, when it is reversed, leaves any effect on the system or surrounding or not. So suppose there is a heat interaction between the system and surrounding. heat Q and Q12 from 2 to 1, right? The system leaves a heat of 30 kg. Suppose when it leaves a heat of 30 kg, the system leaves a heat of 30 kgs, that is minus 30 kgs, right? This heat will be absorbed by the surrounding. So the surrounding will be plus 30 kg, right? Now when it is reversed, Q12, as it moves in the same path, means what energy it has liberated, it should again absorb that energy to reach its initial state. That means it should need plus 30 kg while returning from 2 to 1, because when it moved from 1 to 2, it had left minus 30 kg of heat, and when it want to reach again its initial state, it have to absorb 30 kg of heat. Now when it will absorb 30 kg of heat, this heat will be absorbed from the surrounding, means for the surrounding it will be minus 30 kg. Now as it has reached again its initial position, now we calculate the net heat of system and surrounding. As we see that it is 0 kg in system and 0 kg in surrounding when it reached again the point state 1. That means when it is reversed, when it follows the same path, it doesn't leave any effect on the system or surrounding. The net effect on the system and surrounding is 0. That means it is a reversible process, right? Now suppose, as I said, that is a reversible process is a hypothetical process. Now suppose there is a irreversible process. Irreversible process. It is a wedge, right? And this body moves from 1 to 2. In the forward direction, the process will be 1 to 2, and in the reverse direction it will be 2 to 1. Now just look upon the surrounding. What changes happens in the surrounding when the process which is moved from 1 to 2 in the forward direction is reversed from 2 to 1? If there is any effect left in the surrounding, then we will say that it is an irreversible process. Suppose when it moves from 2 to 1, there will be some energy lost to the surrounding, because due to friction, because it's a wedge and there will be some friction between the contact surface. It is a practical example. There will be some kind of friction between the contact surfaces of this block and this wedge. Now there will be some energy loss to the surrounding, that will be positive. Now when it is reversed from 2 to 1, again when it moves down from 2 to 1, due to the contact surface between the body and the wedge, there will be some kind of frictional loss, which will again goes to the surrounding, which will again be positive. And when the body is returned to the initial position after returning or reversing back, the net effect on the surrounding will be positive. means there will be some kind of effect in the surrounding, means it's a irreversible process. So we got to know about these two important terms, that is reversible and irreversible processes, as these two terms will be frequently used in our thermodynamics. Now moving further, there is another term that is known as quasi-static process. When a process is carried out in a slow manner, then that process is known as quasi-static process. Note: frictionless quasi-static process is a reversible process. As I mentioned earlier, that reversible process is a hypothetical process, and if we think of any type of process which is frictionless in practical atmosphere, is hypothetical. So yes, reversible process is a hypothetical process because a frictionless quasi-static process is a reversible process. Now moving further, we have Gibbs phase rule. According to this rule, it says that P plus F is equal to C plus 2, where P is number of phases, F is degree of freedom. What is degree of freedom? It is the number of independent intensive variables required to fix the state of the system. Means the number of, what is degree of freedom? It is the number of independent intensive variables required to fix the state of a system, right? And what is C? It is number of components. Suppose, let's have an example. Suppose a container contains ice and water. Both has a chemical composition of H2O, so it's a pure substance, as we discussed earlier. Now, if you apply the Gibbs phase rule, P plus F is equal to C plus 2. How many phases does this container has? 2 phases. and components H2O, that is 1. So 2 plus F is equal to 1 plus 2. F will be 3 minus 2, that is 1. It shows that only one independent intrinsic variable will be required to fix the state of the system, this system, right? Now we go to another concept that is known as Zeroth Law of Thermodynamics. Zeroth Law of Thermodynamics. What this law states? It gives the concept of temperature. Right. First I draw this bodies, right? This is two bodies, this is B, this is A, this is C. Now when a body A is in thermal equilibrium, thermal, not thermodynamic, thermal equilibrium with body B, and body B is in thermal equilibrium with body C separately, then body A is in thermal equilibrium with body C. Mathematically, when TA is equal to TB and TB is equal to TC, then according to Zeroth Law of Thermodynamics, TA is equal to TC. Now, what is the significance of Zeroth Law of Thermodynamics, or why Zeroth Law of Thermodynamics is so important? Because it gives the concept of temperature, and in this body B, in this body B acts as a thermometer. Body B acts as a thermometer. In this, another sub topic is thermometric property. thermometric property. What is thermometric property? Is the property which enables to find the temperature of any body. For example, clinical thermometer uses length as thermometric property. Thermometric property. And I will put a note to this before ending my today's lecture, that thermodynamics is based on laws, and these laws are experimentally proven. Means we can't challenge these laws because these laws are experimentally proven, and if we want to prove these laws wrong, we have to experimentally prove what we are saying, right? So with this I leave you, and if you like my video, do like, share and comment, and don't forget to subscribe my YouTube channel, that is AB Study Circle. And if you want to get updates or notification on my new videos, please hit the bell icon on your YouTube app. Thank you.